Hello and welcome to our project progress status. Today we'll be talking about data collection, cleansing, transformation, modeling, and visualization. As a recap, our project had to deliver data collection from 3 websites, an interactive heat map with a dashboard, and an event attendance prediction model. My name is Kifah Awada, and today I'll be talking about data collection and some data analysis. Olga will be talking about data analysis, transformation, and modeling. Taran will be talking about data visualization. So we have to scrape data from 3 websites, Luma, MetApp, and Eventbrite. And this is a small architecture of what we're doing. We have to run a Python script, scrape the data, clean the data, combine the data, and then use it for visualization and forecasting. And we start with Luma scraping. We used a certain logic where we scrap the parent page for the children URL pages, and then we go to every children page or event page, and we get all the details. From Luma, we get around 80 to 100 events in 50 minutes. For MetApp, we get 800 to 1,000 in 40 minutes. And for Eventbrite, we get 900 to 1,000 in 25 to 30 minutes. We really worked hard to increase the efficiency of this scrapping. We used multiple technologies such as Beautiful Soup, Selenium, and APIs. And mainly we use Colab and Jupyter Notebook for code development, but we use PyCharm to run the scraping codes because it shows the highest efficiency in terms of time. Our final data collection has rich data about events such as event time, venue, location, geodata such as latitude, longitude, ticket price, and details about the categories. Our final architecture for every website, we have the scraping script, and then we have cleaning, and then we do combine the new data, and finally we combine and measure it with the old data set. This shows old data, new data combined, remove the duplicate, and refresh the data. And I will go live about this. So here we have Luma websites. We are scrapping Luma websites for today. And it shows that we are scraping 128 events. And for every event, we get the name, the start time, start hour, the day, organization, ticket information, and so on and so on. After this code finished running, we clean the data set. And we get a new clean data. Then this data is moved to this folder where we have the clean data from every website. Then we merge them in the first step. And then the second step, we merge this new data set with the old data set and remove duplicates. And finally, we do some categories update. So here we have a problem with the categories that we have 52 categories, different categories. And we reduced them into 13 categories and 22 subcategories. And we reduced the other or unknown categories by 30%. How we did this, we will discuss this in a code. But first, we try to categorize them using certain keywords. So first we define a subcategory, and then we link a general category. If it doesn't have any subcategories, then it's linked to a general category. After we're doing all of this, we have no nulls in our general category. We have only 13 general categories, but in our subcategories, we have almost 50% of nulls. To solve this, we have to do a prediction. So we are predicting the subcategories. And this is how we do it. So the first code, we run the first code in order to reduce all these categories into these general categories and these general subcategories. And if subcategories are nulls, we take all the nulls and we predict them using the logistic model. And so for this, we use the TF IDF in order to determine the highest occurrence keywords and the details in the details column. And then we encode the subcategories. We have a certain logic for the encoding all of them. And then we use the logistic regression, and with changing multiple parameters, we got an accuracy of 92%, which is a very efficient and good. And this is our confusion matrix showing the difference between the actual and predicted. We can see that 1 and 2, which is dense and music. Thank you.
Hello, I'm Olga Evtushenko, and I will go through your data cleaning, transforming, and data modeling. As we had 3 websites where we get data sets, we cleaned all of them and then merged in one. While I cleaned data sets, I converted and formatted date values to appropriate formats and delete nones, formatted date and time values, then fetched weekday into new column and start time hours, converted weekdays to numeric format to make it better for my future modeling. During the data exploration, I searched how distributed events by day of the week and events in start times. Then, for data modeling, I would like to show you the script. So, the first of all, I explored outliers in number of guests and handled them with I used logarithmics and Q to remove outliers. So then I defined online events. Events which don't have latitude, longitude, and venue, they obviously online and we don't need it, we just drop it. After that, I clean and transform venue and organization. All non-values I filled with unknown. You can see how many was unknown, and if venue has unknown but organization had the values, I replaced venues with venues from organization which had values to not lose this value. Then I cleaned organization and value in the same manner. After that, I cleaned start hour column and made it morning, afternoon, evening, and night. After that, I cleaned transformed weekday and converted it to numeric. Clean ticket price is ticket price distributed not normally, and I also used it like a number of guests, logarithmic, and handle with outliers with Q. Now we can see random forest implementation. Random forest was chosen by our team and our client as the better decision for this model. So in XNumeric, I choose log ticket price, time of the day in numeric, weekday numeric, venue encoded, organization encoded, and general category encoded. And I would like to say, before I will go further, that for weekday, I also use SIN and COS to better encoding. And I choose best parameters before this model implementation. I just put it after when I found it. And here we can see the R square is 0.8, which is quite high, and errors are low. Here we can see feature importance in random forest, and organization and venue, the most important, and actual and predicted values, visualization, which is also good. and residuals and predictors, which just has some outliers, but the most of them are good.
Hi, my name is Saranjeet Kaur and my role in this project is to focus on data visualization. My task was to process the event data, design interactive heat maps, and build a dynamic dashboard that allows users to explore event categories, attendance trends, and location in a very engaging way. So in this presentation, I will take you through the steps of creating these maps and how I structured the final dashboard for the better event analysis. So each event is plotted based on latitude and longitude and also by event name, attendance, and category and location details. So this is the first category, that is the event category. I can show you how it's work. Like when a journal category is selected, any journal category, for example games, it will update the events on this map, like where it is holding and all the details like the event category, the number of guests, where it is located, and which event is going to help this. So we can select more than one event also, like games and dancing. It will change the color. This is the color category for event category. So this heat map helps in analysis the event types attract the most attendance. Like instead of just plotting event location, this heat map scales event markers based on the attendance size. For example, we can use the min and max slider allows users to filter the event-based attendance numbers. We can check the number of attendance, like how many people are going to attend this event. I can show you the example of this also. Like we can filter it about like with category and also with the slider that how many people are going to attend this event. So we can slide it and see the number of guests. This is the so by combining this with the category filter, we can compare attendance trends across the different event types. The next is the event density heat map. It helps to understand how events are distributed. Like each event is plotted on the map using its latitude and longitude. For example, this is the subcategory and the journal category. We can categorize each journal category. It will show that these subcategories are located or are under this journal category. Like for example, for social activities, there are food, politics, and government and friends. Like it allows us to identify event hotspots and helping event organizers understand which location tracks the most events. So we can categorize it by date, category, or in size. Like we can check another also, like for entertainment, it's hobby and film media. We can check it by the number of attendance. So through these steps, we successfully build an interactive event category dashboard that allows users to explore the event data with dynamic filters and visual heat maps. Like for example, we can check any journal category and we'll automatically show us the subcategory under this journal categories. We can add this upcoming event list and we can search it. We can switch to different tabs like I showed you, the event heat map and all these. So this visualization helps in planning, event planning, trend analysis, and location based insights. So our next steps is to improve the dashboard. We are trying to make it very interactive and very useful, and also the next step is to submit all these documents to the client. So thank you so much.